This is the question about the bouncing of ball, in which the ball was initially dropped from a height of 2 meters. Suppose this is the ball and the height of the ball is 2 meters. So in question, it is stated that it would, after bouncing from the concrete, it will it can go up till 80% of the original height. So if we calculate 80% of 2 meter, it would be hardly 1.6 meters. In the next time, it will go 80% of 1.6. 80% of 1.6 is 1.28. In the next turn, again it will go by 80%, and 80% of this one would be 1.024. Next is 80% of 1.024, which would be, I think so, 92, and so on. So the question is how much the distance is, like the information is given about the total distance. One second. The question is show that the distance traveled by the ball until coming to the rest can be expressed by this number. So let's see it's a distance one by one. Let's assume that the ball is going in this way. So for the first bounce, the ball is going to travel the distance of 2 meters. This is the distance traveled by the ball uh, during before first hit. Okay. Now, when the ball will bounce back, it will go till 1.6 and will come back by 1.6. So I can write this 1.6 two times, because the ball will travel 1.6 two times. It's a 2 time 1.6. Then it will bounce back 1.8 and again 1.8 by 2 times. So I can write it. Similarly, the ball will bounce back by, and then it will travel 1.0.2 and 2 times 1.0. And so on. So can I write this 160 as 80%? 80% is 0.8. 80% is 0.8. Off 2 means multiply 2. Actually, I got this 1.6. 1.6 is obtained by calculating 80% of 2. So that becomes like this. So our equation is, so we have something like this. So it is 2 2s are 4 and 4 and 0.8. Now, can I write like the 2 remains as it is? Now, This 1.28 is actually 80% of 1.6, and 1.6 is actually 80% of 2. So our distance goes like this. Now, this distance is 80% of 1.28, and 1.28 is the 80% of 1.6, and 1.6 and 1.6 is 80% of 2. So it would be 4 times 0.8 power 3. So now we have reached approximately to a similar level given in our question. So our distance will have a shape of 2, which is the distance traveled before the first bounce. Then we have 4 times 0.8 powers 1, then 4 times 0.8 power 2, then 4 times 0.8 power 3, and so on. For part B, we can see here to onward we have a geometric sequence. So we can easily find, just ignore this part initially. So our A1 is 4 into 0.8. Our R is A2 over A1, which is 4 into 0.8 square over 4 into 0.8. 4 cancel with 4, 0.8 cancel with this one, so we have 0.8. And we know that uh, are not infinite number of turns, so we can use, in order to find out the total distance. Total distance is 2 plus sum of n terms of geometric sequence. So Sn is A times R1 minus Rn over 1 minus R. I'm using this formula because R is less than 1. You can see R is 0.8, which is less than 1. So I'm using the less than 1 formula. So our A is our A is 4 times 0.8. Then we have 1 minus R is 0.8 power n over 1 minus 0.8. So this would become 3.2, and divided by 0.2. This is, if we divide 3.2 divided by 0.2, it would be 16 times minus 0.8 powers n. So this is Sm. So total distance, we can replace this form back there in equation. So d is 2 plus 16 times 1 minus 0.8 power n. This is our total displaced distance in terms of n.